Raman High School, the pioneer of IIT Foundation in Tri-Cities.
Good morning, students. In the previous class, we have discussed about Rutherford's atomic model. As you know, the Rutherford's atomic model is divided into four parts. The first one is experiment, second one is observations, third one postulates, and the fourth defects of Rutherford's atomic model. We have observed two defects in Rutherford's model. One is this is against the classical laws of physics, and the second is the line spectrum of the atom was not explained by Rutherford. In order to explain the line spectrum, Mr. Niels Bohr, a great scientist, he has introduced his atomic model. In fact, the Bohr's atomic model is the best atomic model. It has given a lot of clarifications regarding the structure of the atom, and it is a modern atomic theory. Now let us go into Bohr's atomic model. So in Bohr's model, what Mr. Bohr has proposed is the electrons in the atom revolve around the nucleus in definite circular paths. This is the nucleus. The electrons revolve around the nucleus in definite circular paths with high velocity. These paths are called orbits or shells or energy levels. The orbits or shells are indicated by the letter N. Once again, electrons in the atom revolve around the nucleus in definite circular paths with high velocity. These paths are called orbits or shells or energy levels. Energy levels. And these orbits or shells or energy levels are indicated by the letter N. N has values 1, 2, 3, 4, or K, L, M, N respectively. First orbit, second orbit, third orbit, fourth orbit, or we can also say it as K shell or K orbit, L shell, M shell, N shell, and so on. And if you see, as the number of orbits increase, the size of the orbits increase. See, the first orbit size is this much, the second orbit size is this much, the third orbit is up to here, fourth orbit is up to here. As the number increases, the size increases. As the size increases, the energy associated with the orbits also increase. So the farther the orbit, the energy is more. Last orbit will have more energy, and the first orbit will have least energy. Last orbit is also called outermost shell. So the last orbit will have highest amount of energy. These orbits, they neither lose energy nor gains energy. Orbits, they don't take the energy, they don't give the energy. That's the reason these orbits are called stationary orbits or stationary states. Stationary orbits or stationary states. But the electrons which are present in these orbits, they can take the energy or they lose the energy. So energy of the orbit is fixed, but energy of the electron is different. Electrons will take the energy and electrons will lose the energy. Then what happens if the electrons gain the energy? And what happens if the electron loses energy? Suppose if the atom has gained the energy, now the electrons will absorb that energy and they jump from lower orbits to higher orbits. After some time they lose the energy, and when they lose the energy they jump from higher orbits to lower orbits. And how these electrons gain energy and lose energy is proposed by Max Planck. Max Planck has given that energy lost or gained should be in the form of quanta, and the quanta has certain value. Now let us see, if the electron present in the first orbit has gained energy and they jump to the second orbit. After some time the electron jumps from second to first. Now the electron has lost the energy, and when it jumps from second to first, the energy lost must be equal to the difference of the two orbits, and that should be equal to the quanta. If the electron gains energy, they jump from lower to higher. If they lose energy, they jump from higher to lower. And the lost energy or gained energy, it should be definitely in the form of quanta. In the form of quanta. And the quanta symbol is H. So energy should be equal to the difference of those two orbits, and that should be in the form of quanta, that is E2 minus E1 is equal to h nu, where h is called Planck's constant. H is Planck's constant. And its value is 6.625 into 10 power minus 27 Henry dash second or minus 34 joule dash second. And nu is equals to frequency. Nu is equals to frequency. So these are some of the postulates of Bohr's atomic model. Once again, electrons in the atom revolves around the nucleus in definite circular paths with high velocity. These paths are called orbits or shells or energy levels. The energy levels are indicated by the letter n. N is equals to 1, 2, 3, 4 or k, l, m respectively, where n is called the principal quantum number. N is called principal quantum number. And this n is called 1, 2, 3, 4. 1 is the first orbital rotation, 2 is second orbital rotation, 3 is third orbital rotation, and so on. As the number of orbits increase, the size of the orbits increase. As the size of the orbits increase, the energy associated with the orbits increase. So the farther the orbit, the energy is more. And these orbits, they neither lose energy nor gains energy, so they are called stationary orbits. And the electrons present in the orbits, they can take the energy or they can lose energy. The energy taken or lost will be in the form of quanta, and that should be equal to the difference of the two orbits, that is E2 minus E1 is equal to h nu, where h is Planck's constant, value 6.625 to 10 power minus 27 per second, and nu is called the frequency. And not only this, Niels Bohr has quantized the momentum of the electron. The electron, when it is revolving around the nucleus, so he has quantized. Quantization is giving a fixed value, that is mvr is equals to nh by 2 pi. The angular momentum of the electron is given a fixed value, that is mvr is equal to nh by 2 pi, where m is mass of the electron, v is velocity of the electron, r is the radius of the orbit in which the electron is revolving. Suppose if the electron is in the first orbit, and that radius will substitute here, so mvr is equals to nh by 2 pi. This is angular momentum of the electron. And when it comes to the spectrum, which is the main defect of Rutherford's model, this Bohr's model has clarified the line spectrum of the elements. How that is, let us go into that now. As you all know that spectrum is nothing but division of energy. For example, you take sunlight, if you take a prism, instead of prism, you know, when you buy a new scale and you see the sunlight in different moments, you will find different colors in the scale. So that means, what is that actually? If you see here, if you take a prism, and now when you incident a beam of white light on the prism, this white light undergoes division into Vibgyor colors, Vibgyor, Vibgyor colors. So what is happening here is the white light, we can see a white light with our naked eye, but that white light has these many colors in it. And this you can see only when you divide that white light into various components. So this is, we can say it is a spectrum. Spectrum is nothing but division of energy is called a spectrum. Spectrum has lot of uses. Scientists discovery of this spectrum has given lot of advantages for us that we learn in your higher classes and in the further lessons also. Now when you see the spectrum, so actually you take hydrogen. Niels Bohr has explained the spectrum by taking hydrogen atom. Suppose the electron of hydrogen is in the first orbit. We have supplied energy to this electron, and when the energy is supplied, the electron jumps from lower orbit to higher orbit. Say 2, 3, 4, 5, 6. Now the electron present in this has absorbed energy and gone to 6th orbit. Now the electron, after staying there for some time, it loses energy, and when the energy is lost, the electron jumps from higher orbit to lower orbit. So while the electron is jumping from higher orbits to lower orbit, the energy which is lost, if you observe it, then it has given some fine lines in the spectrum. So this is line spectrum of the atom. So simply, if you cannot observe with the naked eye, but when you divide that with high powerful microscopes, within the fine line you can observe so many gaps and so many lines in the spectrum. So that is what Niels Bohr has explained clearly. Atoms, when they absorb energy, electrons will gain that energy and they jump to higher orbits. After losing the energy, they jump back to the lower orbits, and that energy which is lost by the electron from higher position while it is coming to lower position, and that energy which is emitted by the atom will have some lines. That is, we call it as the line spectrum. And every substance will have certain form of spectrum. Even in our day-to-day life, we will observe different types of spectrums. For example, sunlight, you will have one color, it has one color, and your mom cooks in the kitchen room, the cylinder, the burner will give a blue flame, so that is one color for that flame, and that means the substance which is present in that cylinder will have that color. And you can see street lights will give different colors, red light and blue lights, green lights, and different substances, they have different nature and they give different colors. So scientists worked out on this, and this spectrum has helped us a lot. For example, what is the secret of the sun? How it is able to release the energy? So this was a big doubt. Now after observing the spectrum of hydrogen atom, scientists have studied the spectrum of different elements, because every element will have its own spectra. The spectra depends on how that element will release the energy. In that again, if that element, atom if you take, and that atom, when it absorbs energy, as you know already, it goes to higher orbits, and while coming back it releases the energy, and that released energy will be observed as spectrum. And different elements will have different spectrum. So what the scientists did is, they have observed the spectrum of sunlight, and they have observed the spectrum of different substances. They compare the spectrum of sunlight with elements. And what is matching is the spectrum of sunlight and the spectrum of hydrogen is observed that they have same pattern. So with that they have come to a conclusion that in the sun there is hydrogen. And with that, further studies have revealed that because of nuclear fusion of hydrogen, sun is able to release the energy. So like this, the spectrum discovery has helped us a lot, and because of nuclear fusion, what happens you all know, and that will be studied in modern physics. And in fact, there is a principle of nuclear bombs. this is about Niels Bohr atomic model, and let us see, he also has some drawbacks. So the drawbacks of Niels Bohr are: number one, this atomic model would explain the spectrum of uni-electron atoms like hydrogen, helium plus, lithium plus, etc. All these will have only one electron. So single electron atom spectra was finally explained by Niels Bohr, but the spectrum of multi-electron atoms was not explained. The spectrum of multi-electron atoms was not explained. And Zeeman and Stark effects were not explained. So, Zeeman effect is nothing but splitting of the spectral lines under the strong magnetic field, influence of the strong magnetic field. Stark effect is splitting of spectral lines under the influence of strong electric field. So, the spectral lines observation under magnetic fields and electric fields were not explained by Mr. Niels Bohr. And this model could not explain the spectrum of multi-electron atoms, it could explain the spectrum of only uni-electron atoms. And this model could not explain the chemical bonds, how the chemical bonds are formed between the molecules, between the atoms to form molecules. That was not explained by Niels Bohr. So this is about Bohr's atomic model. After Bohr's atomic model, so many scientists tried to give clarifications on various aspects, especially regarding the orbits. So a scientist named Sommerfeld has introduced his atomic model called Sommerfeld's atomic model. So let us go into the Sommerfeld's atomic model. So this is very simple. Sommerfeld has observed that electron not only revolves in single path. So within that path, he has observed that there are some multiple lines for the particular orbit. To explain that multiple lines, he has followed a mathematical calculation. Let us look into that. Sommerfeld's atomic model, it especially focuses on suborbits. So that means within the orbit there will be various divisions. So those divisions he has identified as suborbits. For that he has given a simple calculation, that is N by L ratio. So for example, this is the first orbit, second orbit, third orbit and fourth orbit. Suppose N is 4 means fourth orbit. So when N is 4 and L is 4, then the orbit will be circular. Whereas if the L value decreases, L value starts from 0. So L value, if you take N is 4 and L is 3. So naturally 4 by 3, that means this size decreases. So the orbit becomes little elliptical. And when N is 4 and L is 2, the orbit still becomes elliptical. And when N is 4, L is 1, 4 by 1, still the ellipse increases. And when N is 4 and L is 0, the orbit passes through nucleus. So again here is a problem. When the orbit passes through nucleus, the electron is the scope for the electron to pass through the nucleus, where atom will be unstable. So this proposal gives a small conclusion for us that there is not only a particular fixed orbit, but within fixed orbit there will be sub-orbits for the orbit in the atom around the nucleus. This is what we learn from Sommerfeld's atomic model. So dear students, we have learned different things from different atomic models. J.J. Thomson model said that atom is like watermelon and electrons are like seeds. And Rutherford's model has given a beautiful clarification for us that atom is almost empty sphere and the nucleus is there. Within the nucleus there are protons and neutrons, electrons are present in the extranuclear part. And Bohr's atomic model said that electrons revolve around the nucleus in circular paths. Sommerfeld's model said that electrons revolve in circular orbits, but within the orbits there will be suborbits. So still we don't know where the electron is exactly, what is the position of the electron in the atom. To find out the position of the electron in the atom, we have to go into further studies. So that further studies gives full clarity on the structure of the atom. In order to know the position of the electron in the atom, a branch of chemistry called quantum mechanics is to be studied. The quantum mechanics was proposed by Max Planck. And quantum mechanics contain 4 quantum numbers. Each quantum number will give a different clarification. So dear students, the quantum mechanics main job is, after studying the quantum mechanics, we understood that where is the electron in the atom. We will definitely find out the position of the electron in the atom. That is what quantum mechanics will give us. So quantum mechanics contains It contains 4 quantum numbers. First one is principal quantum number. Principal quantum number. Second one is azimuthal quantum number. Third is magnetic quantum number. Fourth is spin quantum number. Principal quantum number, you know, this is indicated by the letter N. Azimuthal quantum number is indicated by the letter L. So azimuthal quantum number is a modification of Sommerfeld's atomic model. Magnetic quantum number is indicated by M. Spin quantum number is indicated by S. Now let us go into principal quantum number. Once again, quantum mechanics is the branch of chemistry which deals with the position of the electron around the nucleus in the atom. Quantum mechanics consists of 4 quantum numbers: principal quantum number, azimuthal